In this video, we are going to work through a practice problem in physics that involves an elastic collision in 2 dimensions. So let's go ahead and jump right into this example. It says, a ball with a mass of 4 kilograms moves with a speed of 5 meters per second toward a second ball with a mass of 3 kilograms, which is initially at rest. After the collision, the first ball is directed at an angle 30 degrees below the horizontal, and the second ball is directed at an angle 30 degrees above the horizontal. What is the final velocity of each ball? So I've gone ahead and sketched out this situation. We have this 4 kilogram ball moving at 5 meters per second towards this 3 kilogram ball. And when this collision occurs, the 4 kilogram ball is sent traveling at 30 degrees below the horizontal, and the 3 kilogram ball is sent traveling 30 degrees above the horizontal. And our question is, what is the final velocity of each of these balls? So in order to solve this problem, what we have to recognize is that in any type of collision in physics, momentum is always conserved. Now, in this case, we have 2 balls that are traveling in an x direction and a y direction, so we have 2 dimensions. So what we can say is that momentum must be conserved in both the x direction and the y direction. So here's what we can write. The initial momentum in the x direction must be equal to the final momentum in the x direction. And momentum is denoted with a lowercase p. And we can also say that the initial momentum in the y direction must be equal to the final momentum in the y direction. So what we're going to do to solve this problem is we're going to write out each of these equations and we're going to solve for any missing variables that we encounter. So let's start with the x direction. What is the initial momentum in their x direction? So momentum is calculated as mass times velocity. So the initial momentum in the x direction, we can say that's equal to mass 1, the mass of the first ball, times the velocity in the x direction of the first ball, plus the mass of the second ball times the velocity of the second ball in the x direction. So this is our initial momentum in the x direction. It must be equal to the final momentum in the x direction. So that would be the mass of the first ball times the final momentum of the first ball in the x direction, plus the mass of the second ball times the final momentum of the second ball in the x direction. So let's go ahead and fill in all the values that we know in this equation. So the mass of the first ball is 4 kilograms, times the velocity of that ball in the x direction, that's 5 meters per second. So we'll say times 5, plus the mass of the second ball, that's 3 kilograms, times its velocity in the x direction. Now for this second ball, we're told that it is at rest initially. So its initial velocity is actually 0. So we'll fill in a 0 right here. And that must be equal to the mass of the first ball, so that's 4, times its final velocity in the x direction. Now, for this first ball, we're told that it's shot in this direction 30 degrees below the horizontal. So its final velocity, let's call that v1 prime. That's this arrow right here. But what we can do is we can break up this final velocity into an x direction and a y direction. So for this direction, we can say that this is the final velocity of the first ball in the x direction, and this represents the final velocity of the first ball in the y direction. And similarly, for this second ball right here, we know that this arrow, this represents the velocity, the final velocity of the second ball. And we can also break that up into the final velocity in the x direction and the final velocity in the y direction. So coming back to our equation, the final velocity of the first ball in the x direction, to calculate that value, we just take the final velocity of the first ball and we multiply it by the cosine of the angle. So in this case, we can say it's equal to the final velocity of the first ball times the cosine of, and remember this angle, this is below the horizontal. So we'll call this negative 30 degrees. So that's the final velocity of the first ball in the x direction. And then we have plus the mass of the second ball, so that's 3 kilograms, times its final velocity in the x direction. So that's going to be the final velocity times the cosine, and this angle, notice this is above the horizontal, so that's going to be a positive 30 degrees. So now let's simplify this a little bit. We get on this left-hand side, we have 20 plus 0, so that's 20, is equal to, on this right-hand side, the cosine of negative 30 degrees comes out to 0.866. So 0.866 times 4, that comes out to 3.464, and that will be multiplied by this final velocity of the first ball. And for this second expression, the cosine of 30 degrees is also 0.866. So 0.866 times 3, that comes out to 2.598. and that's multiplied by the velocity of the second ball, the final velocity of the second ball. So what we'll notice with this equation is that we have two unknowns. We have the final velocity of the first ball and the final velocity of the second ball. So we can't go any further right now. So let's go ahead and save this equation, and then we'll work through the second part of this problem, which is finding the momentum in the y direction. So I'm going to clear a little bit of space here. Okay, so I've rewritten the equation that we just found here. Now let's work on the momentum in the y direction. So we're going to set this up similar to the momentum in the x direction. So the initial momentum in the y direction, that's mass 1 times the initial velocity in the y direction, plus the mass of the second object, or the second ball, times its velocity in the y direction. And that must be equal to the final velocity in the y direction. So that's mass 1 times the final velocity in the y direction, plus mass 2 times its final velocity in the y direction. Now, what we're going to notice in this problem is that the initial velocity in the y direction of this first ball, there is no initial velocity in the y direction because the ball is moving horizontally, so it only has a velocity in the x direction. So this value is actually 0. And similarly, the velocity in the y direction of the second ball is also 0 because it's at rest. So this whole left-hand side is actually equal to 0. So here's what we can write. We can say 0 is equal to, on this right-hand side, let's fill in the values we know. The mass of the first ball is 4, times its final velocity in the y direction. So the final velocity in the y direction, that's going to be calculated as the final velocity times the sine of this angle right here. So what we'll get is the final velocity times the sine, and remember this angle is negative because it's below the horizontal, so we'll say negative 30 degrees. And then we have plus the mass of the second ball, that's 3 kilograms, times its final velocity in the y direction. So that will be the final velocity times the sine of this angle, which is positive 30 degrees. So let's write that. So if we simplify a little bit, we get 0 is equal to the sine of negative 30 degrees turns out to be negative 1/2. So negative 1/2 times 4, that's negative 2. And then we have times the final velocity of the first ball. Plus, for this second expression, the sine of 30 degrees is positive 1/2. So positive 1/2 times 3, that's 1.5. And that's multiplied by the final velocity of the second ball. Now, notice what we can do in this equation. We can move this expression to the left-hand side, so we'll get positive 2 times the final velocity of the first ball is equal to 1.5 times the final velocity of the second ball. And we can solve for the final velocity of the first ball by dividing both sides by 2. So what we'll find is that the final velocity of the first ball is equal to 1.5 divided by 2, that comes out to 0.75 times the final velocity of the second ball. So now notice what we can do. We can plug in this value for the final velocity of the first ball into this equation right here for the final velocity of the first ball. And we'll be able to solve for the final velocity of the second ball. So let's go ahead and do that. I'll clear a little bit of space again. Okay, so I've rewritten the equations. Let's go ahead and plug in this value right here in for v1 prime in this equation. So what we end up with is 20 is equal to 3.464 times 0.75 v2 prime plus 2.598 v2 prime. So if we simplify a little bit, we end up with 20 is equal to, on this right-hand side, we end up with 5.196 times the final velocity of the second ball. And to solve for the final velocity of the second ball, we can divide both sides by 5.196. So what we find is that the final velocity of the second ball is equal to 20 divided by 5.196. That comes out to about 3.85. And we're talking about velocity, so we'll say meters per second. So that's the final velocity of the second ball. And to find the final velocity of the first ball, we can just plug in this value right here in for v2 prime in this equation right here. So what we'll find is that v1 prime, that's equal to 0.75 times 3.85. That comes out to 2.89. And again, we're talking about velocity, so our units will be meters per second. So that will be the final velocity of the first ball. So again, the key to solving this type of problem is recognizing that momentum must be conserved in the x direction and the y direction. And then once you recognize that, you can set up these two equations and fill in all of the values that you know, which will then give you these two equations. And then at that point, it just becomes a matter of solving this system of equations.